Hey, it's time finally, Lucas, for the Pythagorean Theorem. Finally. So, this unit is not in your accelerated book. It's in the 8th grade math book, so we're using a little bit of stuff from there in the notes page. But let's take a look at this Pythagorean Theorem thing. So first off, why is it called the Pythagorean Theorem? Well, it's named for Pythagoras, who was a Greek mathematician and philosopher, okay, way back a couple thousand years ago, right? He had a group of followers of sort of a cult kind of thing called the Pythagoreans, okay, and they lived very simply and they did some weird things. People thought they were nasty or whatever. You can look it up. They did some strange things, but they studied music and philosophy and math, and Pythagoras is credited with discovering the Pythagorean theorem. So what is a theorem? So a theorem, you'll do a lot of this stuff in geometry in high school. A theorem is a math statement that can be proved. So something that you can do a proof to show that it is true. And there are lots of ways to prove the Pythagorean theorem. Again, you can sort of look that up if you like about proofs of the Pythagorean theorem. We'll talk a little bit about one of them here in a little bit. So the Pythagorean theorem is something that works only for right triangles. Right triangles. Okay, what's a right triangle? Right triangle is a triangle that has one right angle or one 90-degree angle. And every right triangle has two sides that make up the right angle. Those sides are called legs. Okay, so the two sides that make up the right angle are called the legs. And the third side opposite the right angle is called the hypotenuse. Okay, the hypotenuse, the third side or the longest side of a right triangle. All right, so the Pythagorean theorem says that a square, or the sum of the squares of the legs of a right triangle, is equal to the square of the hypotenuse. Okay, so typically when you say what's the Pythagorean theorem, people will say a squared plus b squared equals c squared, because that's the math that you do. A and B are the legs. If you square the lengths of both of them, that is equal to the square of the hypotenuse, which means that if you know two of the lengths of a right triangle, you can calculate, you can find the third length. That is the power of the Pythagorean theorem. So one of the proofs of the Pythagorean theorem uses this picture of drawing squares. Okay, when you talk about a squared and b squared, okay, you can basically draw a square on each leg of the right triangle. And if this comes up correctly here, which hopefully it will shortly, we can see a picture here where the legs, okay, so these two sides, so if the leg is 10, then 10 squared is this blue square, the area of this square, and the area of this square. And there are ways that you can break these apart and show that they fit into this square of the hypotenuse. But this picture shows you different, you can change the lengths of A and B, the two legs, and as you do that, as you change the lengths of A and B, you can see how the squares change, and the area of the green square, the square of the hypotenuse, is always going to be equal to the area of the other two squares. So if I can get either of these to slide for me, which it looks like they won't. So anyway, so this is one of the ways that the Pythagorean theorem is proved, is by drawing these squares and breaking them up and showing that they come out equal to each other. All right, so that didn't work out so great, but oh well. All right, so here is how you use the Pythagorean theorem. Right? You're given a right triangle with two sides that you know. In this case, we know the lengths of the two legs, the 30 inches and 16 inches. And so we plug those into the Pythagorean theorem. A squared plus b squared equals c squared. 30 squared plus 16 squared is equal to c squared. We square both of these, and you can use a calculator for all of these. You'll need a calculator for some of them, obviously. Okay? So you square both of these, show what those numbers are, add these together, that's 1,156. So 1,156 is C squared, right? That's the area of this big square that comes off of C, right? The area of this square. Wow, look at that. That is terrible. The area of the square coming off of C is 1,156 square inches, but I don't really worry about that part here, really. Okay, so this square, not much of a square. Okay, so the length of C, though, is then the square root of this. So you have to take the square root of this number. What you're really doing when you solve this equation is you're taking the square root of both sides of the equation. Still maintaining your balance here, doing the same thing to both sides. The square root of C squared is C, and the square root of 1,156 is 34. It happens to be a perfect square. The plus or minus here, the square, either plus 34 or minus 34 would make this equation true, but in the Pythagorean theorem, in the real world, negative numbers don't mean anything, so we don't use the negative numbers. We don't really worry about that. And if you don't write this plus or minus, that's perfectly fine. So then your answer, of course, needs units. So the length of C here is 34 inches. All right, so here's another one for you to try. So we'll kind of do this in steps. So first, find the length of the hypotenuse of the right triangle, round to the 10th. And anytime you get A, B, and C in a problem, Pythagorean theorem problem, A and B are always the legs, and C is always the hypotenuse. Okay? So the first step here, to substitute into the Pythagorean theorem. 13.5 squared plus 7.9 squared equals C squared. Then we square both of these, and don't round these off. Even though it tells you to round to the nearest tenth, that rounding can't be done until the very final answer, because it'll mess up your answer if you round in the beginning or earlier in the calculations. Okay, so the squares of these are 182.25 and 62.41. Add these two things together. 244.66 equals C squared. Now we have to take the square root of this. And hopefully in your calculator, you remember how to do square roots in your calculator. Some calculators do them differently than others. And this square root comes out to, I should have had it on here. Okay, well, it comes out to a crazy long decimal of something. So let me go with my handy dandy here and see what it actually is. Second square root 244.66. Enter 15 point. Okay, the actual answer here is the approximate answer, right? Because this is an irrational number. 15.64161117, right? And that keeps going forever, all right? So in many, many, many Pythagorean theorem problems, because you're doing square roots and they don't come out to perfect squares every time, most of the time you're going to have to round, or a lot of the time. So you'll always have rounding instructions. If you don't have rounding instructions, whatever's reasonable, right? So it wouldn't be reasonable to go past 100th in this problem. Okay. It would not be reasonable to go more than 2 decimal places. And really, because the problems were given to you with 1 decimal, all the numbers were given in 1 decimal place, it's probably fine to have your answer at 1 decimal place. So the final answer here, 15.6 centimeters. About 15.6 centimeters. Hopefully I have as an answer under this box. Come on, Bonds. What do you say? What do you say, Pen? There we go. Oh, no, Riley. Okay, so here it is up here. 15.6 centimeters is your answer. You must have the units if they're given to you in the problem, right? The units have to be the same on all 3 measurements, right? I don't think you get Pythagorean theorem problems where one was in feet and the other one in inches, but if they are, you have to convert them to the same thing. All right, so that's how you find a missing hypotenuse if you know the 2 legs. If you know the length of one leg and the length of the hypotenuse, you can calculate the length of the missing leg, okay? Now we're going to use the same formula, right? The theorem still holds that a squared plus b squared equals c squared. But now it's A or B, and it doesn't matter which one is which. That's the one we're not going to know. Okay, so 8 squared in this case, this leg is 8, the hypotenuse is 24 across from the right angle, and what is B? So 8 squared plus B squared equals 24 squared. Solve this equation for B now. So we do 8 squared here, and we do 24 squared. Then we subtract 64 from both sides so that B squared is equal to 512. And the same way that we had to take the square root to find C, we still have to take the square root here to find B. The square root of 512, approximately 22.6 meters. So your answer is approximately 22.6 meters. And the legs, your answer should come out to be less than the hypotenuse, right? If you make a mistake here and your leg comes out to be bigger than the hypotenuse, you've made a mistake. I will tell you that in 8th grade math, we don't solve this equation like this. Instead, if we're looking for a leg, go straight to something that looks like this. So I will just point it out for you. To do 24 squared minus 8 squared equals B squared. So we call this the subtraction version of the Pythagorean theorem. C squared minus A squared equals B squared. So this is really what you're doing. Either way, the answer here is more important than the algebraic steps for me. Okay. All right, so let's try a couple of these on your own. This one, 3 miles and 8 miles, and then find this missing length in miles. And this one, much smaller than miles, in centimeters. So letter B here. 8 squared is the hypotenuse, so we have 3 squared plus B squared equals 8 squared. It's 9 and 64 when you square them. Subtract 9 from both sides. B squared is 55. And so B equals the square root of 55, which is the exact answer. Okay, this is not a perfect square, so if you take the square root, then your next answer is going to be an approximate answer, about 7.4 miles. Does that make sense? It's less than 8. So, yep, that's good. A reasonable answer. Letter C. Again, the leg is what's missing, one of the sides that makes up the right angle. So 17 squared plus A squared equals 20 squared. 289 and 400, when you square the two numbers that we know, the two sides that we know, subtract the 289 from C squared, you get A squared equals 111. So A is the square root of 111, the exact answer, and approximately 10.5 centimeters. Makes sense? 10.5 centimeters? Yes, that makes sense. You really can always look at the triangle. Some people, I don't know what happened in here, but some people will write A equals 111, right? And if you think about that, when you go back to your triangle, you're like, there's no way that A is 111. I messed something up. Oh yeah, you forgot to take the square root, which is not that uncommon in a regular Math 8 class. Hopefully not here in the accelerated class. All right, so that's the Pythagorean theorem. You can use it to find the length of a leg, or you can use it to find the length of the hypotenuse. The other thing the Pythagorean theorem is good for is to prove what kind of triangle you have. If you know all three sides of a triangle, then you can see if the three sides make the Pythagorean theorem true. If they do, then those three sides make a right triangle. And if not, then it's not a right triangle. And this is actually something that people use when they're trying to determine whether rectangles are perfectly square cornered. They'll measure the diagonals and the two legs, and if they don't match up, then they know that their rectangle is out of square. Okay? So this is called using the converse of the Pythagorean theorem. The Pythagorean theorem says that the sum of the squares of the legs equals the square of the hypotenuse in a right triangle. And the converse is, if the sum of the squares of the legs equals the square of the hypotenuse, then it is a right triangle. Okay? So if I give you three sides of a triangle, in this case 5, 12, and 13 inches, if you substitute them into the Pythagorean theorem, and it comes out to be true, then these three sides make a right triangle. So 5 squared and 12 squared are the two legs, 13 squared is the hypotenuse. Now they don't tell you which one is the hypotenuse here, but the hypotenuse is always the longest of the three sides, right? So the hypotenuse is always the longest. C is always the largest. Okay? 25 plus 144 on this side is 169, and 13 squared is 169. They are equal, which means that this is a right triangle. Okay? Now, if it comes out that it is not equal, okay, then you can actually tell whether or not the triangle is acute or obtuse, even if it is not right. Okay? So I probably should have had an example here, but let's just say in your problem, your a squared plus b squared answer comes out to 78, and your c squared answer comes out to 72. Let me point out here that you don't have to do the square roots at the end, right? You can just see if the squared sum equals the squared hypotenuse. Okay, but if it comes out to this, where a squared plus b squared is bigger than c squared, right? Your two legs are bigger than c squared. This means that your c length, right? The hypotenuse is too small. If the hypotenuse is too small, you would have to squish, right? You would have to squish this leg to like that, and this would be an acute triangle, right? If c squared is too small, then c squared is too small, then it is an acute triangle. If c squared is just right, then it's a right, if c squared is just right, then it's a right triangle, okay? Okay, if c squared is actually too long, right, it's longer than this one, then this leg, in order for it to match up, would have to stretch out this way, and that makes it an obtuse triangle, okay? So if c squared is too big, it's obtuse. If c squared is just right, it's right. And if c squared is too small, it's acute. Make sure you're looking at the c squared number, not the a squared plus b squared number. All right, so let's do an example. 5 feet, 8 feet, and 6 feet. Is this a right triangle? And if it's not a right triangle, is it acute or obtuse? All right, so we'll substitute into the Pythagorean theorem. 8 feet is the hypotenuse, right? Identify that first because it's the longest one, which means 5 and 6 are A and B. So 5 squared plus 6 squared, does that equal 8 squared? 25 plus 36. 25 plus 36 is 61, okay? And 8 squared is 64. So we know it is not a right triangle because they're not equal. So the question then is it acute or obtuse? Look at C. C is too big. If C is too big, then it is obtuse. C is too big, it is obtuse. All right? Now you can try the next couple here, number 2 and number 3. Number 2, identify the hypotenuse. Substitute into the Pythagorean theorem. This side comes out to 676. This side, 26 squared, is 676. A squared plus b squared is equal to c squared, means it is, yes, a right triangle. Number 3. The hypotenuse is C. The longest leg, the longest length is 14. That would have to be the hypotenuse. 9 squared plus 11 squared, that's 81 plus 121. 14 squared is 196. This comes out to 202. So a squared plus b squared does not equal c squared. It is not a right triangle. No. Is it acute or obtuse? C squared is too small, so it is acute. Okay? So that's what we got. Now, one thing, can you tell if it's a right triangle or not, is there's things called Pythagorean triples, okay, which we'll talk about in the next class maybe, okay? Pythagorean triples are 3 whole numbers that make the Pythagorean theorem true, okay? So, in summary, Pythagorean theorem works for right triangles only, right? The sum of the squares of the legs, a squared plus b squared, is equal to the sum of the hypotenuse, c squared. And if you know 2 of the sides, you can calculate the length of the 3rd side. Or if you know all 3 sides of the triangle, then you can determine whether it is a right triangle, or if it is not a right triangle, whether it is acute or obtuse. There you go. In our next lesson, we'll do some real-world Pythagorean theorem problems.